Good morning, children. So, how are you? Hope you are keeping fine, healthy. Okay. So, we'll continue with chapter 3, that's metals and nonmetals. Let us go ahead with ionic compounds. So, in the previous video, we already understood that how ionic compounds are basically formed. So ionic compounds are the compounds which are formed by the transfer of electrons from a metal to a non-metal. Because it was very clearly made clear in the previous video that metals are electropositive in nature, whereas non-metals are electronegative in nature. So therefore the properties of ionic compound, to begin with, if we start with property 1, that's they are formed by transfer of electrons. Hence they are made up of ions, that's cation and anion. So cations are positively charged, anions are negatively charged. So since there are two poles, positive and negative, they are held together with a strong force of attraction. Since there is a strong force of attraction, they usually occur in the form of crystalline solids. Of course, because of the presence of strong force of attraction, they have high melting and boiling point as well, and they are pretty soluble in water, but at the same time they are insoluble in organic solvents. And the last point is very important to note down, that they conduct electricity in their molten state or in solution. Remember, that's a very important board question. They do not conduct electricity when they are in crystalline form. Okay, why they don't conduct electricity? Because the cation and the anion are held together with the strong force of attraction. But when they are dissolved in water, these cations and anions become free to move, and once they become free to move, they conduct electricity. So that's very important question. I'll write down here for you. In molten state, due to the presence of free ions. Okay, free ions means cations and anions, and this force of attraction between these two is broken due to the addition of water. So since there is no more force of attraction left between cation and anions, they are free and hence they conduct electric current. So that's all about your ionic compound. Next we go into very important topic of metallurgy, because we learned various properties of metals, whether it is physical or chemical, but now we need to understand how are these metals extracted and from where should they be extracted. So we have learned in our junior classes that metals occur in earth crust. So these metals which are found inside the earth crust are known as minerals. Remember, I repeat again, all the metals which occur naturally inside the earth crust are known as minerals. Whereas the metal should, or maybe should be present, you can say, in the free state or in the combined state, but that's not a rule. Okay, so the rule says that if the metals are very irreactive, that is they are less reactive, they are inert, like for example we have already discussed gold, silver, platinum, because they are placed below hydrogen in the reactivity series, so they are inert pretty enough, so they do not practically combine with any other substance and they are found in the free state in the earth crust. Whereas other metals are always found in the combined form. Okay, in the combined form like oxides, carbonates, sulfides or halides. So therefore we need to select a particular method of extraction if they are present in the form of oxides. A method would differ if they are present in the form of carbonates or if they are present in the form of sulfides, which we'll be discussing shortly. Okay, another very important thing is this process of metallurgy, that is extraction of metal, should be a very cost effective process. It should not be that expensive. Therefore, the metals which have to be extracted, okay, from the earth crust, I said, are usually found in the form of minerals. But it is not always a rule that metal can always be extracted from any mineral which is occurring in the earth crust. So therefore, there is a difference between mineral and ore. You might have heard about this term ore as well, okay? So what's the difference? Let's understand. If a metal can be extracted from the mineral, I said if a metal can be extracted from the mineral profitably, that is very easily, and it should not be that expensive, then all such minerals are called as ores. So mark a point in your notebook that it is not always possible to extract a metal from any mineral, right? So the extraction of metals can be only done if the process is profitable enough, like if the process should not be that much expensive and all the conditions should be pretty satisfactory for those particular metals, then all such minerals are called as ores. So here we can highlight it. Minerals from which metals can be extracted profitably in a cheaper way and easily are called as ores. So very important statement which you should know, and I'm going to write down here for you. All ores, okay, all ores are minerals, okay, yes, all ores are minerals, but all minerals, all minerals are not ores. Mark this point, a very important point, are not ores. So this statement help us to understand that the minerals from which the extraction of metal is being done easily are called as ores. So for extraction purpose, we don't use the term mineral, we only be specified to use the term ores. Okay, next term I'll highlight it for you, that's gangue. What a gangue? Of course, since metals are present in the earth crust, they will not be pure. They will be along with a lot of impurities. So all such impurities which are present in the earth crust along with such ores are known as gangue particles. And usually the gangue particles are your sand particles, clay particles, some rock, or sometimes two metals may be present together in the combined form as a mixture, and our interest is not in extracting both the metals, okay? For example, usually you will be learning in grade 12 that iron and copper, sometimes they exist together as CuFeS2, copper pyrites. And our interest doesn't lie in extraction of iron, but of course we want to extract copper. Okay, so copper is pretty expensive than iron. Therefore, iron here becomes a gangue for me because I don't want to extract iron. My metallurgy should only extract copper. So such things you should be very careful. I repeat again, gangue are all such impurities which are present along with the metal. It could be other metal in which our interest doesn't lie, or usually it is the sand particles, the clay particles, or the rock particles. But definitely we have to remove all these things, okay? So this is a very important stage of metallurgy, to remove gangue first of all, and then only start with the process of extraction. So let us go ahead with the steps of extraction. So the first step of extraction should be crushing. You know why? Because all these ores are present in the form of huge rocks. So definitely we need to break these huge rocks into small particles so that our extraction is very easy. So therefore, what do? We crush those large pieces of rocks into the small pieces, right? And after that, as I said before, the very important stage before we try to extract any metal is the removal of gangue particles. And that's known as concentration of ore or enrichment of ore. So the removal of gangue particles from your ore is known as concentration of ore. I repeat. And after that comes the process of extraction, which usually involves the process of reduction of a metal oxide to a metal, which we'll be discussing shortly. And the last stage is refining, in which we make sure that the metal is pure enough. Because sometimes, you must be thinking, when we have already concentrated the ore, then what is the point talking about the impurities? Yes, it is pretty possible that some impurities might be left behind. So we have to make sure that after the process of reduction, we refine it so that ultimately the metal which we extracted should be very, very much pure. So here I have already highlighted here what I spoke before. Concentration means removal of gangue particles. And further stages of metallurgy we'll be discussing in next video. So keep watching.